Hi students, good evening. So today we are going to start with the motion in 2 dimensions. Now in this we are going to begin with the general understanding of what is. So though we have it like motion in 2 dimension, we are going to cover both 2D as well as 3D. Okay. So mainly if you look at this so we will break this into motion in 2D. Generally we will break it into three parts. Okay, so one is what we call as the general motion. Okay, the second is the projectile part, and the third one is the circular motion. So these are the three parts we have in the motion in 2D. So general motion means we will try to look at the general 2D as well as the 3D motion. Okay, so this is what we are going to be covering in the motion in 2 dimension. So the name is 2D. We'll also try to cover the general motion, which means the 2D general motion as well as 3D. Okay, then we have projectile. We have different types of projectile, and then we'll also cover the circular motion. So we'll start with the 2D or 3D general motion. So when you say 2D or 3D motion, what is it? The only thing is in the 1D motion we have been taking everything as a scalar by following a sign convention. Okay, we have been taking everything as a scalar by following sign convention. Remember what are the things that we have taken? So the initial velocity, final velocity, acceleration, displacement, all these things we have taken them like what? Numbers, but we have used a sign convention. The quantities in one direction we have taken them positive, other direction negative, when we are using the equations of motion. Correct? That is only when we have constant acceleration. If the acceleration is not constant, means we have the differentiation or integration based relations, which is what? Dx by dt is equal to v, dv by dt is equal to a. This is the differentiation side. Integration is what? Integral v dt is equal to the displacement, integral a dt is equal to the change in velocity. So these are the differentiation relations and these are the integration relations. This is used when generally the acceleration is variable. Correct? So this is what we have in terms of the overall 1D motion picture. But when it comes to 2D or 3D, what we are going to have is the same quantities but being represented as what? Vectors. Because when you're trying to understand the 2D motion, displacement means what? If the 2D motion is in the xy plane, displacement means what? We will have the displacement along the x-axis as well as displacement along the y-axis. Means if you study 2D motion in xy plane, imagine, okay, then what we are going to have? We will be having the displacement vector. It will be having both the I component as well as the j component. If you are studying the 3D motion, means what? The displacement vector will have the I component, it will have the j component, it will have the k component, like that. Okay, now the difference is going to be, we will be talking in terms of not scalar relations but in terms of the vector relations. The difference between the 1D and 2D/3D is what? So we are going to study 2D and 3D together when it comes to the general motion. The difference is what? There we have used the scalar like number equations. Here we are going to use the vector equations. Now again, like the way we did in 1D, 1D we have uniform acceleration motion, non-uniform acceleration motion. Correct? Here also we can have what? Uniform acceleration motion, non-uniform acceleration motion. Uniform acceleration motion means what? Acceleration will be constant. Okay, in that case we can use the equations of motion. You know what will be the equations of motion? Everywhere you are going to get a vector. So s bar is equal to u bar into t plus half a bar into t square. This is the relation between the displacement, initial velocity, acceleration vectors with time. Okay, then V bar is equal to U bar plus A bar into T. All these are what? Vector relations. V dot V is equal to U dot U plus 2A dot S. Okay, so these are what? The equations of motion in the vector form. When we will use them? We will use them for a general 2D motion or 3D motion when the acceleration is constant. If the acceleration is not constant, what is it going to be? Non-uniform acceleration motion. Then we will get what? The differentiation based relations or the integration based relations. Means we will be having what? d r bar by dt, the rate of change of position vector, okay, will be equal to what? Velocity. dv bar by dt is equal to what? Acceleration vector. Okay, now when it comes to integration, we will have to do it separately. Like say for example, integral, if you have integral, right, integral vx into dt. Vx means what? Velocity x component. That will be giving us what is the sx, the displacement along the x-axis. Integral vy dt will be giving us what? Sy. Integral vz dt will be giving us what? Sz. So we will get separate the displacement x component, displacement y component, displacement z component. From that we will be able to tell what is the overall displacement. What will be the overall displacement? Sx into I cap plus Sy into j cap plus Sz into k cap, like that. Okay, so this is how we are going to get the integration and differentiation relations in the vector form. Okay, similarly, you know, the integration of acceleration with respect to time will give us what? Change in velocity, correct? So which means here you are going to get what? Separate for the each component. Integral ax into dt will be giving us what? It will be giving us delta vx, change in the x component velocity. Integral ay dt will be giving us what? Delta vy. Integral az dt will be giving us what? Delta vz. We will get change in the velocity x component, change in velocity y component, change in velocity z component. From that we will get what is the overall change in velocity. What is it? I cap j cap plus delta vz into k cap. Thereby we will get what is the overall change in the velocity. Like that we will get the vector expressions. Okay, so if you have uniform acceleration motion means we will use almost similar looking equations. Non-uniform means we have to use the differentiation or integration based relations, but again we have to tell them in the vector form. Okay, now what we'll do is we'll just start with this question. Look at it. An object has initial velocity 3i plus 2j plus k. This is what? U bar, that is the initial velocity, and an acceleration of I minus k meter per second square. Means what is given? U is given as what? 3i plus 2j plus k. And what is the acceleration given to us? I minus k. Everything is in the SI system. What is the final velocity and displacement in 4 seconds? Means time is given as 4 seconds. In that they are asking what is the final velocity and what is the displacement. What is the final velocity formula? V bar is equal to what? U bar plus A bar into T. Here why are we able to use this equation? Look at the acceleration. What is the acceleration? I minus k, which is what? It's a constant value, right? Is it changing with respect to time? No, it is not changing with respect to time. Means what? It is uniform acceleration. So we can use this equation. Look at this. How I'm going to get the answer for this question? U is what? 3i plus 2j plus k, that is the initial velocity, plus a is what? I minus k into time is 4. So look at this. 3i plus 2j plus k plus 4i minus 4k. So there is a 3i and 4i. What is it? 7i. Okay, only 2j is there. K minus 4k. What is it? Minus 3k. This is what is our final velocity. What is the final velocity value? 7i plus 2j minus 3k. We are using straight away the equations of motion, but in the vector form. Okay, so we got our final velocity. What is the answer? It is what? 7i plus 2j minus 3k. That is the final velocity. Okay, check it guys, you are able to get it or not? Then what is the other thing that we have to solve? We also have to solve the displacement in that 4 seconds time. How do you solve the displacement? What is the relation? The displacement is what? What is the equation for the displacement in the vector form? S bar is equal to what? U bar into t plus half a bar into t square. Means what? U bar is what? 3i plus 2j plus k into t. T is what? 4 plus half into a bar is what? I minus k into t square. Means what? 4 square. 4 square is what? 16. So 2 ones are 2 8s. So look at this. 3 4s are what? 12i plus 8j plus 4k. Okay. Here what is it? 8i minus 8k. Now 12i, 8i, what is it? 20i. Okay. This is 8j only. Plus 8j, 4k minus 8k, what is it? Minus 4k. Clear? So this is what is our displacement vector. This is what is our displacement vector. So we got the final velocity vector as well as displacement vector. Now in these questions, right, if at all they are asking us what is the magnitude, like if they are asking magnitude, right, what we are going to do, we have to, so if say for example this vector, we have to tell the magnitude. How do we tell the magnitude? Root of 20 square plus 8 square plus minus 4 the square, isn't it? It will be what? The root of x component the square plus y component the square plus z component the square. That is what is giving us the vector magnitude, isn't it? So this is about the approach that we have to take for the general 2D motion or general 3D motion. You can see this is what 3D, because look at the initial velocity, it is having the I component, j component, k component. Means what is the motion? It is the general 3-dimensional motion. So it's a very simple approach. What you have seen in the 1D motion, we have used the equations of motion. As it is, we have similar equations. Only difference is what? There we have used the equations in the scalar or numbers. Here you are using the equations in the vectors. That is it. Okay. So this is the approach we have to take to solve the questions in the general 2D or general 3D. In this, just like the way we do in the 1D motion, right? If the acceleration is constant, means what? We have to go for the equations of motion. If it is a non-uniform acceleration, means we have to either use the differential type of equations or integration type. Okay. Now we will go into the concept of the projectile motion. Okay, sorry, before the projectile motion, let us look at the 3 aspects that we will cover in this chapter. What did I say? I said we are going to look at the projectile motion. This is in terms of the order of importance. So what I said, we look at the general 2D, 3D, then we look at the projectile, then we look at the circular, right? But in terms of the order of importance, if you look at the previous year questions, etc., you will see projectile motion will have the higher importance. Then we look at the circular motion, because circular motion will again cover in the Newton's laws of motion chapter. Work energy theorem also will cover circular motion. So circular motion is not going to end here. We are going to just get some initial understanding, and we will keep continuing with the circular motion in other chapters also. And the general cases. So what you saw before is actually what? The general case, general 2D and general 3D. Okay. Now when you look at a projectile motion, what is a projectile motion? So generally when you say for example a bomb is released from an aeroplane in a level flight, means look at it, you have an aeroplane that is going in a level flight, from there you release a bomb. So what will be the motion of the bomb? We'll talk about it. It is going to come down and fall somewhere on the ground. Okay. So the movement of the bomb, once it is released from the aeroplane, right, is only under the influence of the gravity. So no engine or nothing is actually moving the bomb. The bomb is falling under the influence of the gravity. Similarly, if you fire a bullet from a gun, think about it. You have a gun. Okay. So from the gun you fire a bullet. After some time the bullet is going to come and fall on the surface of the earth. If there is no person in between, means what is going to happen? The bullet will travel some distance. After that it will be coming and falling on the surface of the earth. So here the bullet is also having what? A motion under the effect of gravity. Okay. Similarly, if you release an arrow from a bow, what is going to happen? You release an arrow, means the arrow also will travel to some distance and then fall down. If you see a javelin throw, so what is a javelin throw? A person will throw the javelin stick, it will have a path like this. Okay, so this motion of the javelin throw, right? Once he has thrown the javelin stick, then what you see, that javelin stick will be only moving under the influence of gravity, because there is no other force acting on it. So all these, right, we can look at them as examples of, even like there is a football player, so he kicks the football, then what you will see that the motion is going to be like that. It will go to a height and then it will come and fall down back. Okay, so this is what is another example of the projectile motion. So what do you call a projectile motion? So any body which is in flight, which is in motion in the atmosphere, that's the way you will see it. Okay, only under the influence of gravity. It is only moving under the influence of gravity. First we basically give it some velocity. Okay, like in the case of we fire a bullet. How do you fire a bullet? Usually we'll fire the bullet horizontally. You can fire at an angle also, but usually we'll fire the bullet horizontally. If the bomb is thrown from an aeroplane, right, the bomb will be like it's released, means what? The bomb will be initially having a velocity in the horizontal direction. The bomb will be initially having a velocity in the horizontal direction. Okay, if you look at the football player who's kicking the ball, or you look at the javelin throw, then what you see, that we are throwing the javelin with an angle to the horizontal. Okay, so all these are what? These are all the examples where these objects are moving in the atmosphere only under the effect of gravity. Okay, and they are not being propelled by any fuel, like no engine is actually propelling them. Once you kick the football, means the football henceforth is only going to move under the gravity influence. No other thing is acting on it, assuming we are neglecting the air resistance and other things. Okay, because we have to make those assumptions. Otherwise, when you kick a football, right, when the football is in the air, there is going to be an air resistance acting on it. But here when we talk about the projectile motion, right, at least in our discussion, we will keep neglecting that air resistance. The normal problems you solve, right, we will neglect the air resistance. Sometimes in JEE Advanced, they can give us questions by including air resistance. They will ask, okay, so what if the air resistance is there? What is going to be the new equation or new expression? Like that they might ask questions. Okay, but we will see. So this is what is generally the projectile motion. Now we said we have to make some assumptions to study this projectile motion, and one such major assumption is what there is no air resistance, because air resistance is one of the very complicated phenomena. It will depend upon the velocity of the object. It's a very common thing, right? Like you are going in a bike, imagine you go slowly, you will see a very small amount of air resistance. You start driving fast, what do you observe? You will observe that the air is now hitting you fast, isn't it? Means air resistance is going to be depending upon the velocity. So the study of this air resistance, right, is going to be a very complex phenomena. So we assume that there is no air resistance due to the air. Remember, in the vertical motion 1D, we talked about what? The vertical straight line motion, correct? In the vertical straight line motion also, we have neglected the air resistance for the general discussion. Okay, and here, just like the way we have used the acceleration due to gravity value constant in vertical straight line motion while solving problems, right? What did we do? We have taken the acceleration due to gravity to be constant. Here also we have to consider that acceleration due to gravity is a constant. Okay, and we will take the constant value to be what? 9.8 meter per second square. Approximately means we will take it as what? 10 meter per second square. Okay, so here all the points of the trajectory means what? You kick a football, means you kick a football from here, imagine. Okay, so it is going to go through a particular path, isn't it? It is going to go through a particular path. So all the points of the path is what you call as the trajectory. Okay, so the assumption we are making is in terms of the acceleration due to gravity. So what is it? We are assuming that the acceleration due to gravity value will be a constant at each and every point on the trajectory of that particular projectile. Okay, so the G value and direction, both of them will not change. We will always take what G to be vertically downwards. At every point the G will be vertical downwards. But we may have some doubt, because if you look at a normal person kicking a football, it will go from maybe this place to another 100 meters, like that only, maximum I'm saying. But if you look at a missile being projected, at some angle, then the missile is not going to go a small distance, it is going to go into thousands of kilometers. Like you would have seen these intercontinental ballistic missiles. They will be going from typically one continent to another continent, means they will have the range of at least thousands of kilometers. So in that case, right, the earth is not actually flat, isn't it? For small distances, what is the thing that the earth is like a flat. But if you look at the projectile where you are projecting a missile, then what is the thing? We cannot consider earth to be flat, isn't it? So we will have to consider the curvature, means we have to consider that the earth is actually what? Spherical in shape approximately. So if you are doing the design of a missile to hit a target, right, they cannot consider that the earth is flat and do the calculation. They have to consider the curvature of the earth, and then taking that into consideration only they will be able to design that particular system. But for our problems, right, the problem that we are solving, we will usually talk about what? A person throwing a stone, or a football player kicking a football, athlete throwing a javelin stick, like that. For these kind of situations, we can take the curvature of the earth to be negligible, means we can take the earth to be what? Flat. And one more thing is the acceleration due to gravity, right, will also depend upon the rotation of the earth. Okay, so we will learn about it when we go to the gravitation chapter. But here the point is, we will not even consider that. So all these are the assumptions we make for the projectile motion. Now why are we stressing on this? If you are going to change any of these assumptions, then you are going to get into the we don't call it as a difficult problem, we will get into the further level of questions. Like if we consider air resistance, then we are going to get one more variable, like that. Okay, so what you will do is, first we will do the simple derivations, then we will look at the problems where we can have these parameters being changed. So these are the assumptions for what we call as an ideal projectile motion. So what are these? These are the assumptions for the ideal projectile motion. Okay, now we look at what are the three types of projectile we will study. There are three types of projectile we will study. One is the projectile where you throw object at an angle with the horizontal. With a given initial velocity, you throw with an angle to the horizontal. So we will call it as the oblique projectile. So what do we call it as? We will call it as the oblique projectile. Okay, and you have seen, if there is an aeroplane which is going horizontally with some velocity u, it is releasing any object. So if you are releasing an object from a moving body, right, the velocity of that object also initially will be equal to what? The velocity of the moving body. Means, once in the previous discussion, what did we say? We are releasing a bomb from that aeroplane, means the velocity of the bomb will be equal to the velocity of the aeroplane, which will be horizontal. But the bomb will be also going to move downwards because of the gravity. So as a result, it will have a path like this. We will discuss about it. But this projectile, right, is what we call as horizontal projectile. You know why? Because the initial velocity of the projectile, that bomb or whatever you release from the aeroplane, the initial velocity is what? Horizontal. That is why it is called as horizontal projectile. Then we can have an oblique projectile, means you are throwing at a particular angle on an inclined plane. So you are not throwing an object from the flat surface, you are already standing on the inclined plane, you see here, and then throwing an object on the inclined plane. So this is what we call as the oblique projectile on inclined plane. Okay, so generally if you look at the JEE mains level, right, we may get questions from these two areas. If it is JEE advanced, means questions on oblique projectile or the horizontal projectile, we'll have little bit more application level questions linking this concept to some other concept, or we may have questions from the oblique projectile on the inclined plane. Okay, so what we are going to do now is we will go into each of these projectile motions and study them in detail. Okay, so first we will start with the horizontal projectile motion. Okay, before we go into the horizontal projectile motion, we will just look at this principle which will help us in studying or analyzing all the projectile motions in an easy manner. What is the principle called as? The principle of independent motion along mutually perpendicular directions. What does it mean? If an object is moving along the x-axis, okay, it will have some velocity, initial velocity, it will have some acceleration, things like that. Okay, similarly, if the object is also having a motion along the y-axis, it will have its initial velocity, it will have its acceleration and things like that. And the point is, imagine if there is an object, okay, so which is moving along the x-axis. You apply a force along the y-axis. Okay, we apply a force along the y-axis. You know what? The force you apply along the y-axis will not be able to change. The force you apply along the y-axis, right, cannot change the direction along the x-axis. Okay, so if you are having a motion on x-axis, the force you apply along the y direction, right, or the y-axis direction, it cannot change the direction along the x-axis. Similarly, if you apply a force along the z direction, that cannot be changing the motion along the y-axis or z-axis. So the motion along one direction will be independent of the motion along a mutually perpendicular direction. Means what? If you want to study the motion of a projectile, here projectile means we will consider, like say if you look at this, right, all the projectiles, we can consider two directions. One is the horizontal, other one is the vertical. What are the two directions we will consider? Horizontal and vertical. Okay, so since these are mutually perpendicular, right, the motion along the horizontal and motion along vertical, these two are what? Totally independent. Means what? We can study them separately. If say for example the object is having acceleration in the vertical direction, that is not going to cause any impact on the horizontal direction motion. Okay, similarly the displacement in the horizontal direction or the velocity in the horizontal direction, they will not at all be depending upon what are the parameters in the vertical direction. This is what we call as the principle of independent motion. Means, you know, if you have the horizontal direction motion and the vertical direction motion, right, they both will be what? Totally independent of each other. Now when we are going to study the projectile motion, we are going to use this principle. Okay, so first what we will do is we will start with the horizontal projectile. What is the horizontal projectile? We will take a body which is thrown horizontally from a height. So you can see if you are throwing the body from a height, so let us say this is the ground, this is the height h. Okay, from this point we are throwing the projectile with a horizontal velocity u. That is why we are calling it as what? Horizontal projectile. Okay, now what is going to be the motion of the projectile? Think about it. It is given a horizontal velocity, means in the horizontal direction, so we are going to use the principle of independent motion. What is it? In the horizontal direction, what is the initial velocity? It is u. What is the acceleration? Because once you have thrown the object will only have acceleration due to gravity, correct? No other acceleration will be acting on it. That is what is the projectile, right? Only it will be under the influence of gravity. Means the acceleration due to gravity is vertically downwards, right? Is it having any acceleration in the horizontal direction? No. In horizontal direction the acceleration is what? 0. Which means in horizontal direction this is going to have what kind of motion? Uniform velocity motion. Which means what? At any time you see the final velocity, I am talking only about the horizontal side, at any time you see the final velocity is going to be what? Same as the initial velocity, means the velocity part will not be changing. The velocity part will not be changing. In the horizontal direction, what about the parameters of motion for the horizontal projectile? Initial velocity will be u, whatever the velocity with which you throw the object, right? You are throwing it only in the horizontal direction, so that is going to be the u value. Acceleration will be what? 0, because the acceleration of that projectile is downwards. Horizontal, there is no acceleration. So this is like what? Uniform velocity motion, means velocity will be constant throughout. Velocity will not at all be changing. Okay, now let us look at the vertical direction. So we are done with the horizontal, let us look at the vertical. So this is how we will analyze the motion. We will analyze it as what? Separately horizontal, separately vertical. So look at the vertical side. If you look at the vertical side, what is it? You are throwing the object horizontal. So look at it now, you are throwing it horizontal with a velocity u. What about the initial vertical velocity? Initially, is it having any vertical velocity? No, right? Because you are throwing it horizontal, means vertically no velocity is given to it. So vertical velocity is what? 0. And what about the acceleration? Like we said, this is going to move under the influence of gravity, means what? Acceleration is g downwards. Acceleration is what? G downwards. And as per our sign convention, right? Remember, in the vertical straight line motion, what is the convention we choose? Anything upwards is positive, anything downwards is what? Negative, isn't it? That is the convention we choose. Anything up is positive, down is negative. So acceleration, we will take it as what? Minus g. Acceleration, how are we going to take it as? We will take it as what? Minus g. Okay, then this is what? An motion which is having acceleration. This is the motion which is having what? Acceleration. So we will have the equations of motion being used, because this is a constant value of acceleration, isn't it? This is a constant value. The acceleration is downwards g, that is why we are putting minus g, but the acceleration value is constant, right? Because of the assumption we made. What is the assumption we made? Throughout the trajectory or the path, acceleration is not changing, isn't it? That is the assumption we have made. That is the reason why this is like what? This is a uniform acceleration motion. The vertical direction is what? Uniform acceleration motion. Now what is going to happen to that object? You see, it is going to move horizontally, at the same time it is going to come down vertically. So overall path, if you see, this is what is going to be the overall path. The path is going to be what? The path, we'll see that equation of the path, we'll talk about it later, but this is the overall representation of the path or the trajectory. Now what we'll do is we'll try and go look at each of these parameters of the horizontal projectile. So first thing is we'll talk about what is the displacement or what is the trajectory. Trajectory means, generally what we are talking about is the equation that represents the path. Okay, so this is a very standard question in the school level examination. So this equation, we will call it as a parabola. So we'll see. Okay, so the equation of the projectile, the trajectory of projectile, it is a parabola. It's a very standard derivation. Okay, so we also have to find what is the displacement. Now look at this, guys. We are starting from here at a height h above the surface. From there we have given an initial velocity, or we have thrown the object with the initial velocity horizontally. What is the initial velocity value? U. Okay, now look at this. Every time, right, we have to separately write horizontal and vertical. We have to separately write horizontal and vertical. Okay, at time t. Okay, so what about the horizontal direction of motion? It is what? Uniform velocity, isn't it? Because initial velocity is what? U. Acceleration is what? 0. Means the displacement along the x direction. So after time t, the displacement along the x direction, that is what we are representing by the x coordinate. That's what we are representing by what? X coordinate. Okay, displacement along the x direction is what? The x coordinate of the location. This is where the particle is. What is the displacement formula? Because it is a uniform velocity motion, what is the displacement formula? U into t. Correct. Let us keep it as equation 1. Come to the vertical motion. initial velocity is what? Initial velocity is 0. What about the acceleration? Minus g. What about the acceleration value? G downward, that is why minus g. Okay, then what is the formula for the y coordinate? Y coordinate is the displacement in the y direction. Y coordinate or displacement y direction is what? S is equal to ut plus half at square, right? Means this is the equation. No, S is equal to ut plus half at square. In this, initial velocity is 0. That's why half into acceleration is minus g into t square. So look at it. This is the y value. What is the y value? Minus half gt square. Keep it as equation 2. So what are the coordinates of the particular point? It is what? ut comma minus half gt square. So one thing we need to keep in mind is the starting point we are taking as the origin. The starting point is origin, and you see when you go down means you are going into the negative side of y-axis. That is the reason why the y coordinate is coming as what? Negative. So from that reference level you go down means what? You are going onto the negative side of the y-axis. That is why the y coordinate is what? Negative. Okay, so if you want to find out what is the displacement, if you want to find out what is the displacement, how do you tell the displacement? From origin, which is 0 comma 0, you are coming up to the point. What is the point? The coordinates of the point at time t is what? See, all these formulae we have to remember. Okay, what are the coordinates of the point P at time t? It is what? ut comma minus half gt square. So if you want to find what is the displacement, means what? The displacement vector is given by what? X into I cap plus y into j cap only, no? So to this point, the displacement is what? It is the vector from origin to the final point, which is what? X into I cap plus y into j cap, means what? ut into I cap minus half gt square into j cap. This is what is the displacement vector. Okay, like that we will be able to give. Now come to the trajectory. How do you find the trajectory? Trajectory is the relation between the x coordinate and y coordinate. Means we have to give the equation of the particular path. So look at this. X is equal to u into t. Y is equal to what? Minus half g into t square. So from equation 1 we will get t value. T is equal to what? X by u, and substitute this in the equation 2. Means what? Y is equal to minus half g into x by u the square, which is what? Minus gx square by 2u square. That is what is y. Okay, so what is the relation? It is what? Y is equal to minus gx square by 2u square. So the equation is like what? This equation is like y is equal to a into x square, where a is a constant. Look at this. This minus g by 2u square is a constant. So the equation is like what? Y is equal to a into x square. You know this in mathematics, you learn about it. This represents what? This represents the equation of a parabola. So if you have any equation like y is equal to a constant into x square, like that you have equation, means what is it representing? It represents the equation of a parabola. So what is the trajectory of the projectile? It is what? A parabola. How are we able to say that? We are getting the x coordinate, y coordinate and linking both of them, because trajectory means what? We have to get the relation between the x coordinate of the particle and the y coordinate. Generally, if you want to give an equation of circle, right, what is the general equation of circle? With center as origin, x square plus y square is equal to r square, isn't it? Like that for the parabola, right, what is the standard equation? It is what? Y is equal to a into x square. You see here the equation is coming as what? Y is equal to minus g by 2u square into x square. This is like what? If you take the minus g by 2u square value as a constant a, this is like y is equal to x square, hence parabola. Okay, so we have done the trajectory and then also the displacement. Now what we'll do is we'll find out the instantaneous velocity and direction of motion. We'll find out the instantaneous velocity and direction of motion. See, all these are no standard results, we are just deriving them. Okay, so again same concept, we are throwing the projectile from a height h, okay, with the initial velocity u horizontally. Now at a time t, at time t we have reached to the point P. Okay, this is the general point. Okay, here what are we supposed to find? Instantaneous velocity. Now look at this, again same thing, horizontal. Everywhere the two things will come, horizontal and vertical. Okay, so what is the horizontal side? It is a uniform velocity, correct? Acceleration is 0, means at any time the final velocity. So I am going to keep it as what? Look at this, v subscript x. Why I am putting v subscript x? I am trying to tell that this is the x or the horizontal component of the final velocity. Final velocity means we are looking at a time t, that is still going to be same as our initial velocity. Why? Because it is a uniform velocity motion. But what about the vertical side story? Initial velocity is what? Here initial velocity is 0. Vertical direction, initial velocity is 0. Acceleration is what? Minus g. So remember, what is the velocity at time t we want? What is the formula? V is equal to u plus at, right? What is the formula? V is equal to u, which is 0, plus a is what? Minus g into t. So what is the vertical component of that velocity at the time t? It is what? Minus gt. Means the overall velocity at a time t is what? Vx into the I cap plus Vy into the j cap, correct? Which is what? Vx is u, so ui cap minus gt into j cap. What is it? This is the total velocity. What is the total velocity? ui cap minus gt into j cap. If you want to get the velocity magnitude, means what we will do? We will be doing what? We will do root of x component, because if the velocity is like Vx into I cap plus Vy into j cap, what is the velocity magnitude? Root of Vx square plus Vy square. Okay, now we also have to talk about what is the direction. So look at this here, Vx is in this direction. Vx value is what? U. Okay, what about the Vy vertical? It is what? It is what? Minus gt. In other words, why is this minus gt? Means it is gt downwards. What is the vertical? It is what? Gt downwards. Now look at this. So this is what is gt. Now if you want to tell this angle theta is what? The angle of the v bar with horizontal. So what is the angle theta? Angle theta is the v bar angle with the horizontal. So look at this from the right angle triangle, right? What is tan theta? Tan theta is what? Opposite, which is gt by base, which is what? U. Okay, so this is going to give us the angle. And remember one thing, this angle is going to be measured downwards. So you look at it, at any time you see, right, the velocity can be given by what? The direction of the tangent. Okay, so you see at any point the velocity can be given by direction of tangent. You see always the angle is going to be what? With respect to horizontal, we always measure the angle going downwards. We always measure the angle going downwards. And what is that angle? The angle is given by what? Tan theta is equal to gt by u. What is the angle here? It is what? Tan theta is equal to gt by u. So how are we getting it? We are just using that triangle method, right? So whenever we have a vector, it will have the x component and the y component. So from there we will be able to get what is the angle made by the vector with the horizontal. What is the angle coming as? Tan theta is equal to gt by u. Okay, next we look at the most important result, that is the result of time of flight and range. So again, so what we will do is we will take the same concept. So we are throwing an object with the initial velocity u from a height h. Okay, now what is going to happen to this? It is going to come and fall somewhere here. Okay, the time taken for it to reach the surface. So what is the time of flight? Means time of flight means what? You know, it is the time taken for the projectile. It is the time taken for the projectile to reach surface. Okay, that is what we call as the time of flight. So what will be the time of flight? Imagine time of flight means what? It has to come from the top to the bottom. So we can calculate the time of flight just by looking at the vertical direction motion. How? So in that time it is essentially coming down by a height h. Means we know in the vertical direction initial velocity is equal to what? 0. Acceleration is equal to what? Minus g. If you take displacement is equal to minus h. Why minus h? Because we are coming down by h. Then we have to find what is the corresponding time. That is going to give us the time of flight. Time of flight, how do you calculate? By looking at the vertical direction motion. Okay. So look at this. What is the equation we have? Initial velocity, acceleration, displacement, time. What is the equation? Displacement is equal to ut plus half into a into t square. So u is 0 anyway, initial velocity. So what is it? Minus h is equal to minus half gt square. Minus minus is cancelled, which means what? 2h by g is equal to t square, means t is equal to what? Root 2h by g. Do you see something interesting? What is the time here? Root 2h by g. What is this time? Remember, if you generally drop an object from a height h, if you are generally dropping an object from a height h, then it is going to come down in how much time? Root of 2h by g only, no? So which means what? The horizontal projectile, you can just demonstrate this also, like you hold one pen and you try to throw the other pen at the same time. You just drop a pen and then throw the other pen horizontally. The pen that you throw horizontally will travel some horizontal distance, but nevertheless both of them are going to hit the ground at the same time. And what is the time? It is what? Root of 2h by g. This is a very common experiment that we could be doing in the regular classroom. Like if you drop a pen, at the same time you throw a pen horizontally, right? What you see is both of them will be reaching and hitting the ground at the same time. So what is the time of flight value? Time of flight, how are we calculating? First of all, we are calculating by using what? By using the vertical direction motion. So the projectile has to reach the ground, means what? It has to have a vertical displacement of what? Minus h. It has to have a vertical displacement of what? Minus h. So what is the time taken for that? It is what? Root 2h by g. What is the time taken for that? It is what? Root of 2h by g. And this is what we call as the time of flight. Okay. Now all this is for what? All of this is only for the horizontal projectile. So in this time, whatever the horizontal distance covered by that particle, so in this time you can see it is covering horizontal distance, right? That is what we call as the range. What is the range? Horizontal. So these definitions are very standard. Horizontal distance covered by the projectile. Horizontal distance covered by the projectile during what? During the time of flight. During the time of flight. That is what we call as the range. So in horizontal direction, so we have to shift now to the horizontal direction, right? In horizontal direction, what is the initial velocity? U. What about the acceleration? 0. Means this is like what? Uniform velocity motion. So what is the time in which you want to find the horizontal distance covered? Time is time of flight, which is root 2h by g. So look at this horizontal direction, the displacement value x is equal to what? Already we have got it. What is it? U into t. T is the time. So we want range, means range is generally given by the symbol r, capital R. Range will be what? Horizontal distance covered in the total time of flight, means u into what is the time of flight? It is root 2h by g. So this is what is the formula for the range. What are we doing here? Simply we are taking the horizontal direction motion, which is a uniform velocity motion, and in that we are using the equation. What is it? The displacement is equal to what? Initial velocity into total time of flight, which is root of 2h by g. Okay. So this is what is the expression for the range and the, what are these? These are the expressions for what? Expressions for the range of the projectile and the time of flight. Okay. Now what we'll do is we'll quickly look at one question. Let us see if we are able to solve this question, means we will be able to okay. So look at this. An aeroplane is moving horizontally. Where? It is moving horizontally at an altitude of 8 kilometers. So look at this. We have an, it's not a good drawing, but nevertheless. Okay, so we have an aeroplane. Okay. It is flying at how much altitude? 8 kilometers. Okay, horizontally. What is the speed? 500 meters per second. Okay, if a food packet is released from the plane, means we are just releasing it. Remember, if you release an object, right, means what? The initial velocity of that food packet is going to be what? 500 meters per second, and the food packet is going to travel in which path? It is going to travel in the horizontal projectile motion, isn't it? What is the horizontal range of the packet when it falls to the ground? It's a straight question, right? It's a formula question. If you remember the formula, means straight away you can answer. What is the range value? U into root of 2h by g. Here they are saying take the g as what? 10 meter per second square. It might help us. So look at this, guys. If you are able to get the answer for this, they are asking us what horizontal range. Range value is what? U, which is, what is the horizontal velocity? 500. Everything here is in the SI system. So R, if you take everything in the SI unit, R is going to come in what? Meters. 500 into root 2 into h. What is h? 8 kilometers. We can't take kilometer. 8 kilometers means what? 8,000 meters. So 2 into 8,000 by, what is it? Denominator is what? 10. Correct. So 10 ones are 10 800s. 2 into 800 is what? 1600. What is root 1600? 40, which means 500 into 40. So look at this. What is it? 20,000. Means if you just release that food packet, right, after how much horizontal distance it is going to fall? It will be falling after a horizontal distance of how much? 20 kilometers. So that is the reason why when during the rescue operations, etc., right, like there is a flood or some kind of an cyclone, etc., when the relief operations are going on, typically what they will do, they will try to drop these supplies or food packets, everything from the aeroplane. So if your aeroplane is going at a very high speed, then what is going to happen? Like you have to drop food packet, like at how much? You have to see if there is you see a group of people standing here. Okay, you have to observe them from how much distance? 20 kilometers distance, and then you release the packet. Then the packet will be able to travel the path and come and reach these people. Okay, so that way, if you try to do these operations by moving an aeroplane at such high altitude and at high speed, it is going to be very difficult to make sure that things are reaching people. That is the reason why what they do, they will use typically these low flying vehicles like helicopter, etc., because they will be more comfortable. Helicopter means you can actually make it stall in the air also for some time. Okay, and then you will be able to just drop off all the things to the surface below as it is from a very low height, so that even the imagine if the food packets and all these are coming dropped, even forget about the food packet, even really packed material itself, if you're dropping at height of 8 kilometers and all, think about it. By the time it will be falling to the ground, what will happen to it? The package will just burst off, right? Of course, you will do a lot of precaution in making sure that there is a proper sealing, etc., but still there is a danger of such things happening. Okay, so this is about the question. It's a very straightforward. And remember, guys, in horizontal projectile motion, if you are getting questions, means we will get straightforward questions like this. Okay, we will not get much complication unless in JEE Advanced they are trying to make some changes to the question. We'll look at it. For that, we should go to the next concept, right? When we go to the laws of motion or energy, then we will be able to understand what kind of changes or modifications can be done to the horizontal projectile motion question itself. Okay, then we look at the next question. Look at this one. If projectiles A and B are projected horizontally with different velocities from the same height. Look at this. A is thrown with a different velocity, B is thrown with a different velocity. Here I just have one straight question. Okay, you see that A is covering less horizontal distance, B is covering more horizontal distance. Means what? Think of it in normal sense, right? You just throw with small velocity, it will go and fall at a small distance. You throw it with a higher velocity, what do you see? It will go and fall with a longer distance. Means what? The velocity with which you are throwing A, the UA value will be less than UB value. That is why the B is able to go to a longer horizontal distance, but both of them are thrown from the same height, okay, but with different initial velocities. And a third particle C is dropped from the same point. Like I said, right, third particle is dropped from the same point. As it is dropped. Look at the question. Then we have to tell which of these options is actually suitable. Option A, they talk. Option 1, they gave a statement. Option 2, they gave a statement. Option 3, they gave a statement. Option 4, they are saying all are correct. Look at this, guys. Option 1 is what? All three particles will take equal time to reach the ground. Already we have did this in the derivation, right? You have a horizontal projectile. You drop an object from the height h. Both of them are going to come down in how much time? Root of 2h by g. Both of them are going to come down in how much time? Root of 2h by g, isn't it? Which means what? Which means here in this case we have two horizontal projectiles, but doesn't matter. A also as well as B, all of them, because they are all thrown from the same height, means for the particle C which is dropped, what is the time it takes to come down? Root 2h by g. For the particle A which is projected horizontally, time to come down is what? Root 2h by g. For the particle B which is projected horizontally, time to come down is what? Root of 2h by g. So all three particles will take equal time to reach the ground. So this is correct. Now can we, by this itself, can we comment on the option? No, because see, we have all are correct. So that can also be possibility, right? Just because we got option or correct, we cannot just take it and move on. So whenever in questions like this, right, you have all the above or true and things like that, we have to be checking at least minimum 2 answers. Look at the second statement. Their net velocity would be different, but all three particles possess same vertical component of velocity. Okay, what about the vertical component of velocity? Remember, we did the derivation, right? What is the Vy value? Minus gt. See, we should just keep recalling those things, huh? What is the horizontal component of velocity? That is going to be same throughout the horizontal projectile motion. So for A, what is the Vx value? It is equal to UA. It is going to be throughout the motion constant. For B, what is the Vx value? It will be UB. Whatever is the initial velocity we have given for the B horizontally. For C, what is the Vx value? 0, because you are dropping it. You are simply dropping it, right? Means for the object which is dropped, initially the horizontal velocity is 0, vertical velocity is also 0. Okay, which means if you look at the overall velocity of A, it will be given by what? The vertical component as well as horizontal component. Overall velocity B means given by vertical component and horizontal component. Overall velocity C means given by vertical component, horizontal component. Overall velocities will be different, but look at the vertical component. All of them, they have the same vertical velocity. Even the object which is dropped. Remember, if you simply drop it, right, think about it. The initial velocity is 0. Vertical direction only, look at it. Initial velocity is 0. Acceleration is what? Minus g. In time t, what is the vertical component of velocity? V is equal to u plus at formula, right? U is 0, a is minus g. So Vy is equal to what? Minus g into t. Same. So A, B, C, all of them, net velocity or total velocity will be different, but all the three will have the same vertical component of velocity, which means second is also correct. If you are confident about 2 of the statements, right, then we can straight away go and tick saying that okay, option 4 is the correct answer. Why? If we got 2 of the, because this is not a multiple MCQ, assuming, okay, if it is a JEE advanced type multiple MCQ question, means again we have to be careful, okay. But if it is JEE mains type question, we see that 2 of the options are correct, means what? The only possibility is all of them must be correct, isn't it? We will look at the third also. What is the third one? Look at this. The trajectory of particles A and B will be a straight line with respect to particle C. Interesting one. What is it? They are talking about the trajectories. What they are saying? Trajectory of the particles A and B will be what? It will be a straight line with respect to the particle C. Now the thing is, they are going to come down with the same velocities vertically. At any point you see, they will be at the same vertical height. At any point you see, they will be at the same vertical height. Now think about it, right? What do you observe? C is here. At that point, A is here, B is here. So they are on same straight line. After some time, C is coming here. A is here and B is here. They are again on the same straight line. With respect to C, when you observe, A and B are on the same straight line. But what is the observation? Initially, they are all at the same point. After some time, A is moving little bit farther on the same horizontal line. A, B, C all are on the same horizontal line. A and B are moving little bit farther. After some time, they are even more farther moving. So what do you see? The trajectory of the particle A and particle B with respect to C. We already did a derivation. What is it? The trajectory of particle A is what? It is a horizontal projectile. What is the derivation we said? It is going to represent a parabola, correct? The trajectory of particle B is also what? Parabola. When you are observing from the ground, normal person, you see A motion, you see B motion, what is it? It is a parabola. But we are saying observing with respect to C. So what does C see? C will be observing always A and B, they are on the same straight line. Whatever line that C is there, A and B are also on the same straight line, isn't it? They are going to come down at the same time simultaneously. But over time, what is the distance between C and A and C and B? The distance is increasing. So with respect to C, when you observe, right, what is the observation going to be? It is like A and B are moving on the horizontal straight line. With respect to C, when you observe, right, it will appear as if A and B are moving on the horizontal straight line, because who is observing? C is the observer. So C will only see that A and B are moving farther from it along the horizontal direction. So the trajectory of the particles A and B is going to be a straight line with respect to what? With respect to C. With respect to what? C. Okay. So this is about, so the answer is what? All four are correct. So this is about the horizontal projectile. In the next session, right, we will start with the oblique projectile. Okay.